Assalamu alaikum dear students. In this video we'll see some small introduction part and we'll get into the sums of exercise 5.5. From 5.2 to 5.3 we have been using the concept of e power x and log x. First of all we should know what is e power x and what is log x. We all know about the trigonometric function sin x, cos x, tan x and other things. Like that we have a function called as exponential function y equal to b power x, where b will be greater than 1. So any function which is of this nature, like b greater than 1 means it can be 1.1 whole power x, it can be 2 power x, it can be 3 power x. So any function of this nature we call it as an exponential function. We call it as an exponential function. Right, now this is a new function that we are discussing now. So whenever we study about any function, immediately the next thing that we have to discuss is what is the domain of the function and what is the codomain of what is the range of the function. Domain and the range of the function. Now the domain of this particular function is whatever real number you substitute, you will definitely get an answer for it. Right, so domain for this particular function is entire real number. Whether you can, for example if I take y equal to 3 power x, let me substitute in the place of x 0.1 or 2, 3 power 2 I know it is 9. If I put 3 power 0.1, it is difficult for us to calculate, but we can calculate and we will get the answer. Right, so for all the real numbers we will definitely get an answer over here. So the domain is entire real number. Right, the range is, now whatever real number I substitute, I'll definitely get a positive number as answer. I'll not get negative numbers or 0 as my answer. The reason is, let me check. If I substitute positive number, 3 power 3 is 27, 3 power 4 is 81. So if I substitute any positive number, we are clear with it. We'll definitely get a positive number. What is 3 power 0? 3 power 0 is 1. So if I substitute 0 or positive number, the answer will be definitely positive. That we don't have any doubt about it. We are clear with it. What if I substitute a negative number? If I substitute in the place of x, if I substitute a negative number, will I get the total answer, final answer to be negative or positive? I told that for all the values, I'll definitely get my range to be all positive numbers. Right, so let me make it clear for you. Let me check it. Let me put 3 power in the place of x. If I put minus 3, what is 3 power minus 3? I can write 3 power minus 3 as 1 by 3 power 3. Now 1 by 3 power 3 is nothing but 27. So 1 by 27 is a positive number or negative number? It is a positive number. It is a positive number. Right, so whatever value, even though if I substitute a negative value, the final answer will be a positive real number. Right, so the range, therefore the range is all positive real number, all positive real numbers. Right, and one more property that we can discuss here is there is a common point for all the exponential function. Whether I can, let me take it as y equal to 2 power x or y equal to 3 power x or y equal to 7.1 whole power x, whatever it is, there is a common point for all the exponential function. If I substitute x in the place of x 0, what will the answer here? If I put x equal to 0, I'll get y equal to what? 2 power 0 is what? Y equal to 1. Yes, here also x equal to 0, 3 power 0, that is also 1. So x equal to 0, here also I am getting 1. So this 0 comma 1 is the common point for all the exponential functions. 0 comma 1 is the common point for all the exponential functions. Right, so this is what we call it as an exponential function, and these are the three characteristics of it: the domain and range and the common point. Right, now every function has its inverse. We didn't go through the first chapter yet. In that we will discuss about the inverse of a function. Right, so every function has its inverse. For example, for you to make it clear, for y equal to x square, what is the inverse of it? Inverse function is nothing but square. For squaring, the inverse function is square root. Right, so y equal to root x is nothing but the inverse of the squaring function. For squaring function, what is the inverse? Square root. For cubing function, y equal to x cube, what is the inverse function? Y equal to cube root of x is the inverse function. Right, so like that, for exponential function also we have a function which is the inverse of it. That is what we call it as logarithmic function. Logarithmic function is nothing but the inverse of it. Y equal to log of x base b, where b will be greater than 1. Now this is what we call it as a logarithmic function. This logarithmic function is nothing but the inverse of an exponential function. Right, so inverse means what will happen? the domain and range will get shifted to the opposite direction in most of the cases, not in all the cases. In most of the cases, if we to find the domain and range of an inverse function, if we what we have to do, we have to change the range to the domain. We should write the domain as the range. What are the domain of this logarithmic function? Domain of logarithmic function is nothing but the range of exponential function. What is the range of exponential function? R plus. So that will be the domain for my logarithmic function. And what is the range of my logarithmic function? Range of logarithmic function is nothing but the domain of the exponential function. Domain of exponential function is entire real number, right? So domain of the logarithmic function is all positive real numbers, and range of logarithmic function is all real numbers, right? And the common point also we have to shift it. There 0, 1 is the common point. Here 1, 0 is the common point. 1, 0 is the common point. In order to understand this more clearly, let me give simultaneously change exponential function to a logarithmic function so that you will understand it. If 2 cube equal to 8, this is in exponential form. How can I write it in logarithmic form? I can write it as log of 8 base 2. Log of 8 base 2 is nothing but 3. Yes, let me tell you with the help of squaring. If I tell that 3 square equal to what? That is squaring. 3 square equal to what? 9. Yes, square root of 9 is what? What number? Square root of 9 means what? How will I understand it? What number if I multiply 3 square means if I multiply 3 2 times, what I'll be getting? This is what we call it as squaring function. What is square root? What number if I multiply 2 times I'll get 3? I'll get 9. What number if I multiply 2 times I'll get 9 to be my answer. We all know that whether if I multiply plus 3 also I'll get plus 3 into plus 3 plus the answer will be 9. Minus 3 into minus 3 also the answer is 9. Got it? So the square root of 9 the answer is plus or minus 3. The same way 2 cube is what means exponential function. 2 cube is what? 2 cube is 8. This is exponential function. Log 2 power what is 8? 2 power what is 8? 2 power 3 is 8. That is what exponential function. Can you able to understand? It is nothing but the reverse process. 3 square is what? Is squaring function. What number if I multiply 2 times I'll get 9? That is my square root. 2 cube is what? That is exponential. 2 power what is 8? That is nothing but my logarithmic function, right? So like so this is what exponential and logarithmic function is. If you want us to discuss more about this exponential function and logarithmic function, there are some more things in the introduction part which is not necessary for your exam point of view, but if you want to discuss, please let us know, comment in the comment section below. We'll discuss about it. Right now we have some in exercise 5.5 we have in exercise 5.5 we have some differentiation sums which is based on this concept of logarithmic differentiation, right? Those things inshallah we'll see in the upcoming videos. If you have any doubts, please comment in the comment section below. If you like our video, please click the like button, share with your friends and subscribe our channel, and to get the regular notifications of our video, please don't forget to turn on the bell button. Thank you.